This is going to be 23-1. We're going to take a look at the chain rule, and we're still in differentiation. Now the chain rule is just another way for us to be able to take the derivative. The power rule is very limiting. We learned these special trig derivatives and inverse trig derivatives. We learned these special derivatives, but it's still more of like a this equals this equals this, and it's almost like you're just replacing what's being written. Now, what happens if I have this derivative here, y equals sine of x cubed? If I were to take the derivative of that, that is not cosine of x cubed. And the reason is, it's because of that cube. That a cube changes it a lot. So the x cubed prevents us from taking the derivative, and from what we know of this so far, there's nothing that's going to help us. And so that's why we need to know the chain rule, because we're going to use the chain rule to be able to take a derivative of this. So the chain rule is essentially a composition of functions, and what we're going to do is we're going to use substitution to be able to help us with this. So usually it's whatever is like on the quote-unquote inside of our function, we're going to substitute it. So I'm going to say u equals x squared minus 3. So that means that this f of x is going to be u to the fourth. Now if I take the derivative of this in respect to x, what's going to happen is I'm going to get 4u cubed du. Well, this part is easy, right? That's just for, we said u is x squared minus 3, and that's to the third. So this part here, I'll highlight it. This is this. But what about this du? Right? That du is an issue. And so this is actually saying the derivative of u. So I need to look at u, and I need to take the derivative of this. Du equals 2x. And so now I can substitute that and multiply by 2x. And so now I get 8x times x squared minus 3 cubed. And so that right there is going to be our answer. So in this one here, let's look at a few examples. Let's find the derivative. So u equals x cubed minus 2x. So that means I get 5u to the third. So now I need to take the derivative of this. So I get 15u squared du, because that's the byproduct, because I'm not taking it in respect to x. There's no x. Well, I am taking it in respect to x, but because there's no x, I have to have that du at the end. And so this is 15. We said u is x cubed minus 2x. Now du, so I have to take the derivative of this, so I get 3x squared minus 2. And so this is an acceptable answer. I know it looks crazy, right? But that's an acceptable answer for our derivative. Let's look at another one. The cosine of 5x squared. So I'll say u is going to be 5x squared because when we took the derivative of this, cosine of x, right? There's no power in that. So now this is going to turn to the cosine of u. So now taking the derivative of this, you get negative sine of u du. And so now this is negative sine of 5x squared times du, so du, so it'll be times 10x. And so that right there is going to be the derivative. This one here, ln, so ln of u, and so we know that that's going to be 1 over u times du if I take the derivative. And so that's then going to be 1 over x cubed plus x times, now if I said u is x cubed plus x, taking the derivative of that, so it'll be times 3x squared plus 1. So my answer is going to be 3x squared plus 1 over x cubed plus x. I know I kind of did that one a little fast, but I think you understand what I mean by the u and the substitution. E to the 5x, so this is e to the u, so u equals 5x. So that means taking the derivative of this is e to the u times du. And so that's still going to be e to the 5x. And then du is just 5. So that's going to be 5 e to the 5x. So to conclude this lesson, what is the chain rule? The chain rule is a way for us to take the derivative of more complicated functions. And essentially what we're doing is we're breaking our function into a composition of functions to be able to then take the derivative of it. Now, a way to memorize this, the derivative of the outside of our function times the derivative of the inside of our function. So in this instance, this was the outside of my function, which I took the derivative of. This was the inside of my function, which I took the derivative of, and I multiplied those two together. This was the outside of my function, so I took the derivative of that. This was the inside of my function, and so I took the derivative of that and multiplied those two together. Now, this does conclude our lesson. If you do have any other questions, please leave them in the comments.